ಹಾಯ್ ಹೆಲೋ ಎವ್ರಿವನ್ ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. ವೆಲ್ಕಮ್ ಬ್ಯಾಕ್ ಟು ಮೈ ಚಾನೆಲ್ ವೈಷ್ಣವಿ ಸ್ಟಡಿ ಝೋನ್. ಎಲ್ಲರೂ ಹೇಗಿದ್ದೀರಾ? ಆರಾಮಿದ್ದೀರಾ ಅಲ್ವಾ? ಹೋಪ್ ಯು ಆಲ್ ಆರ್ ಡೂಯಿಂಗ್ ಗುಡ್. ಸೊ ವಿತೌಟ್ ನೋ ಫರ್ದರ್ ಗೋ, ಲೆಟ್ಸ್ ಬಿಗಿನ್ ವಿತ್ ಟುಡೇಸ್ ವಿಡಿಯೋ. ಸೈಕ್ಲೋಟ್ರಾನ್. ಸೈಕ್ಲೋಟ್ರಾನ್ ಅಂದರೆ ಏನು? ವಾಟ್ ಡಸ್ cyclotron mean? A cyclotron is a machine that accelerates charged particles or ions to high energies. It was invented to investigate the nuclear structure by E.O. Lawrence and M.S. Langston in 1934. Both electric and magnetic fields are used in the cyclotron to increase the energy of the charged particles. As both the fields are perpendicular to each other, they are called cross fields. In a cyclotron, charged particles accelerates outwards from the center along a spiral path. These particles are held to spiral trajectory by a static magnetic field and accelerated by a rapidly varying electric field. After knowing the structural explanation about the cyclotron, now let's move on to learn about the working principle of cyclotron. A cyclotron accelerates a charged particle beam using a high frequency alternating voltage which is applied between two hollow D-shaped steel metal electrodes known as the Ds inside a vacuum chamber. The Ds are placed face to face with a narrow gap between them, creating a cylindrical space within them for particles to move. Particles are injected into the center of this space. These are located between the poles of electromagnet, which applies a static magnetic field B perpendicular to the electrode plane. The magnetic field causes the path of the particle to bend in a circle due to the Lorentz force perpendicular to their direction of motion. An electromagnetic force, an alternating voltage of several thousand volts, are applied between the Ds. The voltage creates an oscillating electric field in the gap between the Ds that accelerates the particles. The frequency of the voltage is set so that particles make one circuit during a single cycle of the voltage. To achieve this condition, the frequency must be set to particles' cyclotron frequency. Alright then, let's know the expression for cyclotron frequency. Here it is: F is equal to QB by 2 pi m. B is the magnetic field strength. Q is the electric charge of the particle. M is the relativistic mass of the charged particle. Next, let us learn expression for particle energy. The energy of the particles depend on the strength of the magnetic field as well as on the diameter of the Ds. Centripetal force required to keep the particles in a curved path is given by the formula Fc is equals to mv squared by r. The force is provided by the Lorentz force Fb on the magnetic field B. Fb is equal to QVB. Equating the equations, we get mv squared by r is equal to QVB. V is equal to QBr by m. Hence, the output energy of the particles is given by the expression E is equal to Q square B square R square by 2m. Uses of cyclotron. For several decades, these were the best source of high energy beams for nuclear physics experiments. However, these are still in use for this type of research. Treatment of cancer. Cyclotron can be used in particle therapy to treat cancer. Using the ion beams from cyclotron can be used to penetrate the body and kill tumors by radiation damage. Let us learn few more limitations to cyclotron. Cyclotrons cannot accelerate electrons because electrons are of very small mass. A A cyclotron cannot be used to accelerate neutral particles. It cannot also accelerate positively charged particles with large mass due to the relativistic effect. Okay, then this all about today's video. Last but not the least, I would like to bring to your kind notice that please do wear mask and maintain social distancing. Don't be panic, but be careful, stay safe and stay healthy. Don't forget to like, share, comment on the video. If you did not subscribe my channel yet, please do subscribe my channel. Thank you for watching.